In vibration data acquisition, one should also ensure the correct instrumentation is used. The specifications of the instruments like the transducer used shall be understood beforehand. Signals conditions shall also be evaluated if the signal needs special treatment before it is sent to the DAQ device. In data acquisition, one could follow the 3Rs rules to ensure one can acquire a good and reliable data. So what are the 3Rs? In data acquisitions, the 3Rs are referred to the resolution, range, and rate. The first R is the resolutions. Here, it is referred to the amplitude resolutions, or how accurate the signal is discretized in the y-axis of time signal. It is usually defined in terms of bits and discretize the signal amplitude range to the resolution of power of 2. When we have an amplitude resolution of 1 bit, it discretizes the amplitude axis or the y-axis into 2 power of 1 or 2 grids. It means when we have an analog or continuous sine wave, it can only discretize into 0, 1, -1. Signal with value will be grouped into 1 or -1, giving a square wave as shown in the red line. In this case, a continuous sine wave, when it goes through a 1-bit ADC, will discretize to a square wave instead of sine wave. So when we have higher amplitude resolutions, for example 4 bits, it will discretize into 2 power of 4 or equivalent to 16 grids. In this case, the sine wave is having better amplitude resolutions to be discretized into a closed sine wave. A 16-bit ADC will discretize the signal amplitude range to a resolution of 2 power of 16 or equivalent to 65,536 grids. Currently, in the market, we can find 24 or 32 bits which give a very good discretization of vibration amplitude in the digital form. The second R is referred to range. As we discussed in signal conditioning device topics, signals are sometimes very weak to be analyzed, in which the signal to noise ratio is too low, and sometimes the signal is too strong and high until it exceeds the allowable range the DAQ can read. So, this signal needs to be adjusted in signal conditioner, either with amplifier or attenuator, so that the signal can exploit the total input range of the ADC, and eventually obtaining the maximum dynamic range to allow wide range of the measurements of the highest and the lowest level of the signal. The third R is rate, or so-called the sampling rate. As we discussed earlier, to prevent the aliasing effect, one should follow the Nyquist theorem. To obtain accurate frequencies of the original signal, the sampling rate must be 2 times greater than the maximum frequency component of the measured signal. To obtain accurate shapes as well as the frequency of the original signal, it is advised to have sampling rate of at least 5 to 10 times greater than the maximum frequency component of the measured signal. In the selections of the DAQ system, usually we look into several important specifications. In vibration measurements, IEPE accelerometers is commonly used. The DAQ must be able to supply or generate small currents to power up the accelerometers. The DAQ should also allow for switching between AC and DC coupling. AC coupling normally used for dynamic signal and always for IEPE accelerometers, while DC coupling should be used for transient signals and may be needed for very low frequency signals. The DAQ should also come with the anti-aliasing filters, which could avoid aliasing effect, which we have discussed earlier on. We should also look for the DAQ with precise sampling and simultaneous sampling, meaning to have high sampling rate as well as allowing data to be sampled simultaneously across all channels. Besides having good resolutions in the x-axis of the time data, we should also look for DAQ systems that come with high amplitude resolutions in the y-axis of the time data. It is usually represented by bits. Higher bits you have, better amplitude resolutions. For example, 32 bits have 2 power of 32 grids in the y-axis. Higher amplitude resolutions usually give higher dynamic range, meaning the DAQ can measure a wide range of low-level to high-level signals. In addition, we should also ensure that the DAQ system should have low cross-channel talks. It means the channels are well separated and no signal is transferred from one channel to another. Lastly, a good DAQ system should always give a good cross-channel match. Under the same conditions and hardware use, every channel of the DAQ system should give the similar signal or data. So, by now, you should have some knowledge in how to select a reasonably good DAQ system for a reliable and accurate vibration data acquisition.